Today we're going to talk about the laws of exponents, the fundamental laws of exponents where all other laws arose from. But first we have to be very familiar with the meaning of an exponent and its base. Say for example, we have 3 raised to 2. In this case, 3 is the so-called base and 2 is the exponent, which tells us how many times the base is to be used as a factor. Thus, 3 raised to 2 means 3 times 3 and not 3 times 2. Moreover, the answer here is 9 and not 6. Now why am I telling you this? Because very often do I encounter students who would mistakenly multiply the base and the exponent and therefore arriving at the wrong answer. Now before we proceed with the lesson proper, let us first answer a few examples involving base and exponent. For 3 seconds, 10 raised to 2. Time is up. The correct answer is 100. For 5 seconds, 3 raised to 3. Time is up. Correct answer is 27. And for 7 seconds, 3 raised to 4. Alright, time is up. The correct answer is 81. If you get at least 2 correct marks, I believe you can already proceed with the next lesson. And if not, well, I guess you need to work on some more exercises like what we just did. And before we continue, pa-shoutout po muna ako kay Jerome Mongcal. Hi, Yom! One of the best students that we've had at Rawis High School and who is now a licensed professional mathematics teacher as well. Congrats! And welcome to the field. And salamat din sa pagsubaybay sa mga walang kwenta kong vlogs. Salamat. Now, the first law that we will have is the product of powers. Say we have any number x raised to 4 multiplied by x raised to 2. What do we get? Now, by expanding this expression, we get x times x times x times x for the first given power and x times x for the second. If we count the number of x's, we have 6 and therefore the answer to this problem is x raised to 6. And that is by counting. But let me ask you, using the exponents 4 and 2 respectively, how will we get 6? Yes, that is right. We simply add these exponents. This is what the product of powers says. If we multiply powers of the same base, we simply add their exponents. So remember, for any number a and for any positive integers m and n, a raised to m times a raised to n equals a raised to m plus n. So if we have y raised to 10 times y raised to 11 times y raised to 12, we will have y raised to 10 plus 11 plus 12, which will give us y raised to 33. Now let me clarify this thing to you, which is based from my years of experience in teaching. More often than not, a lot of students write, in this case for example, 33 instead of y raised to 33. Well guys, they are absolutely different from each other and never considerably correct, so you gotta be extra careful with your answer. Now let's have the second law, which is the power of a power. Let us consider this expression, m raised to 5, the quantity raised to 3. If we expand this expression, we will have 3m's raised to 5. That is m raised to 5 times m raised to 5 times m raised to 5. You might want to expand expression further, but if you notice, this expression can already be solved using the previous law, which we are multiplying powers of the same base. Thus, we will have m raised to 5 plus 5 plus 5, which is equal to m raised to 15. Now from m raised to 5, the quantity raised to 3, we now have m raised to 15. The question is, how do we get 15 using 5 and 3? Yes, you are right. Without expanding the expression further, we can simply multiply the two exponents, and that is what the power of a power says. Remember, for any number a and any positive integers m and n, a raised to m, the quantity raised to n, is equal to a raised to m times n. So if we have x raised to 3, y raised to 8, the quantity raised to 4, we will have x raised to 3 times 4 and y raised to 8 times 4, giving us x raised to 12, y raised to 32. The next law that we will have is the quotient of powers. Well, this is just pretty much the inverse of our first law, which is the product of powers, meaning instead of adding their exponents, we do the reverse, so we subtract their exponents. But let us illustrate this with an example. Say we have w raised to 6 divided by w raised to 4. If we expand this expression, we will have this. And we can cancel out each pair of x's in the numerator and the denominator, since if we divide two non-zero numbers, the result is 1, and multiplying any number by 1 does not affect its value. After cancellation, what is left for us is w raised to 2. And how do we get 2 using 6 and 4? Perfect. We subtract the exponent in the denominator from the numerator, and this is what the quotient of power says. For all integers m and n and any non-zero number a raised to m divided by a raised to n is equal to a raised to m minus n. Let's work on this. P raised to 20 r raised to 20 divided by p raised to 11 r raised to 16. Applying the law, we will have p raised to 20 minus 11 and r raised to 20 minus 16, giving us p raised to 9 r raised to 4 for an answer. There you have it, guys. Thank you for watching.